So I was trained as a coral reef ecologist, and I did most of my research in coral reefs around the world. And I loved being in the field, but I had an early experience at NCEAS as a graduate student participating in a working group which brings together a team of scientists to address kind of bigger scale questions, synthesizing data that's already in hand to try to gain new insight from that data. And the projects I was involved with were super exciting and kind of converted me to the power of data science to address research questions rapidly and at scales that you just can't do with field science. And there was a conference in Okinawa, Japan in 2004 that convened all of the coral reef scientists from around the world. So I was sitting at lunch with my wife, who was also a coral reef biologist at the time, and some other friends. We were like, we want to see the last of the best pristine coral reefs in the world before they disappear. So this was just a lunchtime conversation that ended up literally changing the trajectory of my research and really my life, because we realized that it was pretty hard to actually identify and find the places that were pristine or untouched by human activity. And it's hard to map the absence of something. And that made us realize that we could flip the script and ask where are impacts happening, and where we don't see them, those are likely to be the last of the pristine areas. And once we thought about doing that for coral reefs around the world, we're like, well, let's just do it for the whole ocean. And that's what led to the whole work to map the cumulative human impact on the world's oceans. And that was the paper that we published in 2008. It highlighted something like 41% of the world's oceans were heavily impacted already. The results were so striking. We had front page science news coverage in almost every paper in the world. It kind of changed, I think, a lot of the way that people thought about the urgency and the scale if we're going to manage the oceans in a more sustainable way. From that moment of publishing that, I realized it would be nice to think forward, like what does the future hold? Because if you can understand and anticipate the future, it really changes the way that you would make decisions. So I knew back then that it would be useful to have that forecasted view into the future, but we just didn't have the information, the data available to be able to do that effectively. And it took basically almost 20 years to get to the point where the data were finally available to be able to address this kind of question. What does the future look like? And that's what really launched this most recent project a couple years ago to begin to take advantage of all this information, all the data, all the work that so many other scientists around the world have done to make it possible to look into the future and say, well, here we are today, where are we going to be in 20 or 30 years, and how can we use that information to make better decisions? I think the thing that was most surprising to me was just the scale and pace at which that is going to happen. You know, our earlier results suggested a steady but slow increase in these kinds of pressures across the ocean. What we found, more than a doubling, potentially a tripling, is way faster than I anticipated. And that really put a fine point on the need to act comprehensively, carefully, strategically, but also quickly to start to mitigate a lot of these pressures in time to let our oceans continue to survive and hopefully thrive in the future. And so our results, our work, is actually sort of a menu of options and an opportunity to change the future, not a foregone conclusion that we must live with. And in that sense, it gives me hope that there are a lot of pathways to a more sustainable future that our results suggest. When you look at something comprehensively, it shows you that not only are there many things contributing to the problem, but many ways to contribute to the solution.